Hey there folks, welcome back to the channel. This is a special road edition, I guess we could call it, of the office hours. Been doing some travel, visiting some folks in the upstate New York area, and had some downtime today, so thought I would put together office hours video and kind of see how it goes. My theory was all you need is like a camera and some questions and you can do an office hours from anywhere. So let's we're putting that to the test here. We're putting that to the test today. Here at an Airbnb, so I found a spot. I guess this one is as good as any others in the place. Hopefully the lighting will work. I feel like it's a little bit dark here, and I didn't bring like a ton of camera equipment. Probably should, I guess, invest more into camera equipment. Maybe some people want to send me some camera lighting equipment. I don't know. But anyway, so yeah, so I'm on the road doing some travel and whatnot, and I have a list of questions I thought I would go through, and we'll put it together, and hopefully it comes out okay, and this will work for folks. Speaking of travel, I do actually have a schedule update. That is for upcoming conference DevNexus, which is in Atlanta, Georgia, April 9th through the 11th. There's going to be a U.S. community booth, and I know at least myself, and I believe Dave Kramer is going to be there, who maintains the JDBC driver. It's a large Java conference. I believe there'll be folks from Yugabyte as well, is my understanding. I think we'll have a couple other people as well. So putting that together, but I do expect to be there, and that is early April at DevNexus. You can check it out online. It's a very large conference in the Atlanta area. So if you're anywhere in that area, feel free to stop by. Be happy to chat. You can meet some other Postgres folks and, come and hang out. Should be a good time. So that's the main schedule note. Other than that, just relaxing and doing some open source work here and there, helping people out, and keeping it going, trying to keep it real, trying to keep it warm. That's what I'm really trying to do up here in New York. Quite a bit colder than Florida. We'll see. The heater may kick on while I'm doing this. Wouldn't be sad if that happened. But with that, let me go ahead and I'll get into some questions. I picked some questions out, and what I think I'm going to do, I'll drop the last question because something came up on Slack earlier today, and I thought it was an interesting enough sort of train wreck when I saw it, and then I had sort of some advice for the original poster as to what I thought they should do, and then I thought in a more nicely worded question for office hours, this would be good to put in there. So I'll just give you the scenario and then kind of give the advice. And I think that may be useful for some folks out there, and good things to keep in mind. So without further ado, let me jump into the questions, and we'll see how far we can get. So first question is from Zhenyao Zhao. Hopefully I didn't butcher that too bad. If you have duplicate indexes on the same column, and I should correct myself, because they actually spelled it correctly. If you have duplicate indices on the same column in Postgres, will it have a negative impact on query performance? And I didn't give the disclaimer, but I guess I should. This is obviously not professional database advice. This is an old DBA consultant just spouting random noise into the world to see what sticks. Now, if I were getting paid by the hour on a consulting, I would tell you that the answer to this is it depends. And that actually is the correct answer, because it does depend on what you mean by will it impact query performance. Now, so the simple it wouldn't actually impact your query performance would be if you say I've got one query and I'm going to run it over and over again, but I happen to have two indexes there. Is that going to cause it a problem? And in that kind of scenario, it's a very narrow scenario, I would say no, it's not. It doesn't actually matter that the other index is there, but there are a bunch of reasons why that other index could affect you. And we could start with, it does actually depend on what is the nature of the query you're talking about. For select, once you've planned your query and executed it, Postgres isn't going to actually look at the other index, so it doesn't really matter if it's there or not. But if you are doing any kind of update or insert or delete, then Postgres actually has update files, and likely, very much so, update files in those other indexes, right? So when it writes a new row, it's got to write it in the table, and then the column data will quite possibly have to go into the index, depending on the nature of that, and then possibly go into the other index if they're on the same column. right? So you can get right amplification on this. And I do talk about this. If you look in the channel for the Think Like a Postgres part 2 video, which is super long and daunting, but actually it's one of the very early parts in that video. I talk about how indexes work and how they affect queries, and this whole thing about right amplification when you have duplicate indexes. So would definitely be worth checking that out. There are other sort of cases that I know people make arguments about, like, well, if you have 2 indexes, then the query planner has to actually choose between those 2 indexes. If they're actually duplicate indexes, where it's like the same columns, it's actually the same index, there's just 2 of them, like, yes, but probably query planning time is such a small percentage, of your world in that scenario that, like, that's really not the thing you need to be worried about. And I certainly do, encourage you to not have duplicate indexes. One of the things that I would say you should be checking for when you're doing index maintenance and management is getting rid of duplicate indexes. It certainly isn't going to help you in any way, right? So even if your query, the question I think is, like, if you're thinking, is the second one slowing down the execution of this specific query as it is running? Like, that second one most likely isn't actually slowing down the sort of in-flight execution, but there are all kinds of negative side effects of having it. So definitely something you should be trying to get rid of and trying to deal with. So hopefully that helps answer that. And again, like, go look for the Think Like Postgres part 2. It's in the first, like, 30 minutes of that video. And it goes into, like, talking about even at the page level and stuff, not about how indexes are dealt with. So certainly would be worth a look if you're wondering about this kind of a thing. Okay, question number 2. Can you see a history of queries run on a Postgres database? And the simple answer to that is no, you cannot. If you want to try to see the history of queries that are run, again, there really is no way to do that. There are places you could look to try to get an idea. There's an extension called pgstat statements. If you have access to that, and most providers do actually give you access to that, or you can just install it. It comes with the base Postgres. If you have pgstat statements going, you can see like parameterized versions of all the different queries that have been run. So that could be useful, but it doesn't show you, like, every query and every combination of parameters and that kind of a thing. So that's not going to give you, like, a real true history of queries. Really the only way to get that, I guess there might be 2 ways, but to me, like, there's a config parameter log statement. You set that equal to all, and then every query that is run on the system will be written into your logs. You could get the history of the queries that way. I know that sounds as awful as it kind of is. The other way that I was thinking, I suppose if you had auto explain configured, and auto explain is a tool that kind of dumps explain plans. If you had that, or if you did, like, logmin duration, so these are both other ways to kind of back into it. Logmin duration set with, like, the smallest possible value. In theory, that would probably give you every query that's going to be on there. I think if you can set it to, I think it's 0. If you set it to 0, basically everything gets printed out with its duration, and -1 turns it off, if I remember correctly. So with a 0, you would get all the queries that are being run. With auto explain, I think the problem is whether or not you would actually get the query, but I was thinking you could configure that to, like, as anything over 0 time, like, dump the plan out, and maybe that gives you some information on what the queries are that run. But if you're just like, hey, how do I get a log of every query? Like, there is no way to actually do that. Log statement equals all is probably the best answer for that. And that's going to dump all the stuff into the logs, and you'll have to parse all that out and deal with it. So it's not impossible to do. I think the other thing, I guess I'll just mention, if you're thinking about this for like auditing purposes, usually where this kind of thing comes up, you could look at, like, PG Audit as sort of a tool that's more at the database level for auditing changes to tables, if that's the kind of thing you're looking for. But that really isn't a history of queries either. It's more sort of a history of their effects. So maybe it doesn't do what you want. So yeah, great. Good times. Okay, question 3, coming from Johnny Uloa. How do you scale a relational database like MySQL, Postgres, or Oracle? And there's, that's a quick, 30-second answer. So there's a lot that does go into that. I'll give you sort of a very basic outline. And again, this is another one, actually, I have talked about this in talks way back in the day. If you look for the talk, database scalability patterns, I've got at least one version of that talk in the channel, and I think maybe two. And they're both more or less the same. I think one has better audio than the other, so pick the one that sounds better. Neither of them may sound good because they're both from a ways back. But the basic idea is usually you start with a database, you start throwing data in it, and then at some point, what most people will do is they'll start with partitioning some of the larger tables, and then you're basically staying on one system when you do that, and you're slicing the table up into different partitions in whichever way that might be. Sometimes it's like a user ID, more often it's like a timestamp. So whichever way that goes for you. Once you do partitioning and that's not enough, then what people tend to do is they do sharding, which is sort of splitting some of the database out onto other systems. But what I use, I think in that talk I use the terminology just to sort of make clear, they switch from horizontal partitioning in this context, which is regular partitioning within one system, to vertical partitioning, which means I'm going to take some subset of tables that create an application in and of itself, and I'm going to move that into another database. So I'm not splitting a single table across multiple things like a Citus might do. What I'm actually doing is I'm saying hey, these 7 tables over here, they're all used by this one application or one piece of our application. So we're going to split that piece of our application out into its own database system and make something different with that. And so one way you could think of that, a lot of times people do that with a login service, right? So we're just going to move the users table out of our system because that's super huge and that's going to be its own database. And then, the rest of the database stays in the existing cluster that was there, and we set up some kind of token or whatever. But then when you're beating on it with login attempts, right, it's not affecting actual, whatever it is that you're doing. And if you think about the Stack Overflow one, I think the thing, if you were to look at that, if I were going to vertically partition that, probably sort of weird because there's just not a lot to Stack Overflow. It's not there's a lot of different pieces and applications that require very wide schema, right? And this is the case where when you look in your schema, you got 40 or 50 tables or more than that, right? And then you would say these 7 to 10 tables, we could split them off into their own system, build an app against those 7 to 10 tables, and then just deal with the references back. You could say well, we'll put the posts in the post database, right? And then the users will be in the users database. If you were going to try to vertically partition, right, in that. Once you find out, so if you say I split the users off into its own table, into its own system, if I split the users table into its own database cluster, where only users in there and we're still outgrowing the hardware, then you go into actual sharding, as it tends to be thought of, where you take some subset of the user's table, right, and you split that into 10 or 20 or 50 or 100 or whatever number of servers that you want to have, and each of those becomes its own cluster, and then you figure out how you're going to manage that. So, and that's where something like Citus would come in, typically, something along those lines, or you could do it in the app layer, whatever. But again, the talk database scalability patterns goes into that, and that talk was actually written at a level where it mostly is any relational database. This is just the stuff that people go through. And thinking about things from a schema design thing, you want to have, do you want to do sort of random, we can split, a given users table into, put it on another cluster and split that up into maybe 10 servers or whatever. But when you do that with the users table, do you do that with just the one table? You can do that in a Citus context, it would be, you're going to, maybe you would move multiple tables. And this is where you get into this idea of swim lanes, where what tables do we want to take with the users table so that we can keep relational information all within a given cluster, and then split that out across other things. And so maybe you're partitioning based on other columns and whatnot across your sort of shard circle. So I get into that video. That's, I guess, maybe more of an advanced technique, but it's been used to scale, sort of way simpler versions of MySQL, Postgres, those kind of databases at some of the bigger companies that are out there. So If you really want to know, like I would say, go look at that as like 45 minutes or whatever on that topic gets into it. But the short answer is really like people start with partitioning, then they usually split out a few tables into its own database system, and then they go to like sharded thing when the one table doesn't fit anymore into a given cluster. So hopefully that's useful. Okay, question number 4 is going to be from Alexander, and he asked, is it safe to take PG dumps while users are using the individual database? Yes. All right, that's simple. I mean, that's what PG dump is for. The whole point of it is that you can take online dumps, I guess. I would like to say online backups, just to sort of trigger the people that don't think PG dump is a backup. But you can take those dumps online concurrently with whatever traffic's going on in the database, and it doesn't matter. And the only caveat, of course, is that if you are doing that, obviously any changes that might be going on while you're doing the PG dump, you're not going to capture those, right? Anything that's changed after your PG dump start, you're not going to actually get that data in your dump file. So be aware of that. But other than that, like, yes, you absolutely can do that. And that's actually the whole point of PG dump, is for it to be safe to do while you have concurrent activity going on. So, all right. Question number 4, short and simple. Okay, so let me give you question 5, which is not actually a question, but I will just outline the scenario for you. The original question, and this is total paraphrase, but it was somebody who was working on porting SQL Server data into Postgres. And the problem that they were hitting was they had in SQL Server, I guess, and I forget, I don't think it's a datetime, whatever they call their datetime type function, or not function, but datetime data type, maps basically over to a timestamp TZ in Postgres. And theirs by default has 7 decimals of precision, whereas we only have 6 decimal places of precision in Postgres by default. So the problem was sort of like, well, I have these 7 decimal precision, right, essentially timestamp TZ7 values. They don't go into my timestamp TZ6 data type on the Postgres side. And how do I resolve that? And there was some discussion that went back and forth. There was a suggestion of potentially using, there's an extension, because of course it's Postgres, there's always an extension. There's an extension called, I think it's called timestamp 9, or maybe it's timestamp TZ9, which gives you 9 decimals of precision. So there was one like you should use that, but it turned out this guy's using like a cloud Postgres system, so he can't, I don't think he has access to be able to put that extension into his cloud service. So that probably isn't going to work for him. And then the solution that he came up with, I guess, I don't know, was that essentially like, he's like, well, what I'm going to do is I'm just going to take the values from SQL Server and I will store them as text data in Postgres. And he looked and he was like, well, I can do like greater than, less than comparisons with this data. And that seems to work. And I can use max on it. So I can do like max on the timestamp value, which is actually a text. And that seems to work as well. So, and I think he was a little confused as to why that actually worked. Like, I wouldn't have thought max would work. And that's like, well, so this is where I came along. And I'm like, yeah, max will work from a, like, does the SQL run and give you an answer back? That does work. Because it's just taking your text data and then doing the comparisons as if it was text. So it doesn't actually know that it's a timestamp value, right? It has no knowledge that these set of characters are supposed to represent a time or time zone or anything related to dates or anything like that at all. It's just text data to it. But you can do those things, right? You can select, A less than B, and you'll get false, I'm pretty sure. So I guess maybe that's collation dependent. Technically, it certainly is. Anyways, but so I'm like, yes, you could run those. I'm like, but I don't think that's really what you want to do or should do. My sort of, and this is where I kind of gave this as like, here's what I think you need to do. This is how you need to approach this problem, because I don't think you really want to use text to store this. So the first step of what you should do is you should go to your cloud vendor and basically present this problem to them and say, hey, I'm trying to move from SQL Server and move this data into a Postgres system that runs in your cloud that you guys operate. And I need to know how to do this and maintain that precision, right? Or what is your official response to how do I maintain that precision? And I would be interested to see what the cloud provider says about that. And part of this is because my understanding, and this is one of those, like, if anyone knows, correct me if I'm wrong, I believe that the Postgres code itself can do up to 7 decimals of precision itself. It supports it if the underlying operating system supports it. But I think that on most Linux-based systems, you only get like 6 digits of precision to those timestamps. And I will say, and I do end up saying this, that like that's more precision than anybody needs, more than likely. And I'll touch on that a little bit more in a second. But in any case, like, but if you're in the cloud, right, you can't upload the extension for timestamp 9, and you're beholden on whatever OS they have picked and what those libraries are. So it's kind of up to them. Like, you need an official response from them to tell you what they think you should do. And so that was sort of step one, is get an official response from the vendor, because you're limited based on what the vendor can do. As far, and I don't think the answer is going to be your company's going to have to switch vendors or whatever. Like, that's probably not going to happen. But you need that as sort of like some ammunition, because the other thing you're going to do is you're going to go to whoever is the application owner. And this was one that, like, people had asked, like, hey, can you just change the precision? Like, how do you know? He's like, well, I'm not the application owner. I don't know if I can do that. So I was like, okay, now you need to go to the application owner and you need to tell them that, essentially, like, Postgres, this cloud Postgres system that you're using doesn't actually support 7 digits of precision time data, which is what you have in SQL Server. And you need to find out from them and sort of tell them, hey, we have some workarounds that we can use in order to preserve the 7 digits of precision, but they will make this solution sort of more complicated for sure, right? And so think of the solution as, we're going to actually pull the data over, store it as text, and then we can cast it into timestamp TZs if we need to, or display it back as text or whatever, and try to manage it that way. But if you're storing that as text, like, it will be more expensive because it's more storage. It will more than likely be slower, right? One, because it's more storage, but then also, like, you're dealing with like text data and whatnot versus the timestamp stuff. So that probably isn't going to be as fast either from that standpoint. And then the third thing with that is, I also would have a concern about sort of subtle application logic bugs, where the app is handing off this data to you, aka the database, and saying, hey, like, I need the max timestamp back. Can you give me that? And it's expecting that you understand that this is time data and it's not just a series of characters and numbers, right? And if you don't understand that as the database, and you give back an answer, like, you may not be giving back the answer that the app thinks that it's getting. And that's how subtle, like, logic bugs pop up in your application code when you do a migration. And I've definitely seen those kinds of problems before. So the key really is, if you go back and you say, look, I got to work around, we can do it if we have to, but it's more cumbersome, it's more expensive, it's probably less performant, and could introduce subtle application logic bugs. Or we can just drop, that 1/7 decimal of precision and go with 6 digits of precision, and we'll probably be good to go. And this is where I'm like, 99.9 probably, I wanted to say, I've got 6 digits of precision percentage. Sure, that you don't actually need that 7th digit of precision in your data, because most applications really don't need that. There's basically like 2 scenarios I can really think of off the top of my head, at least, that would go for that. One would probably be like high frequency trading. But I can also tell you that, having done enough, whether it's from a user side doing trading, or if it's from the consultant side, or sort of building out on the technology side, I've been on both ends of this spectrum. Even in those scenarios, like the 6 digits, there's plenty of those that I've built on Postgres with 6 digits of precision. I guess that's the short way to say it. So having built systems that were involved with trading and whatnot on Postgres with 6 digits of precision, I know that 6 is enough even for those scenarios. So, I could see maybe you need something for legacy reasons or whatever. You got to figure something out. But by and large, anything going forward, 6 digits is probably going to be enough, and you could probably get by with that. And so that's one. The other one is, I think there are certain, astronomical workloads And I don't know. There's the timestamp 9, which was suggested. I didn't really look at it too close. That extension, I wouldn't be surprised if that came out of like some university that was doing astronomical workloads. Like there's some stuff like that around like date times and whatnot, that when you are dealing with things on, either, I don't know if you want to call it like a geological scale or a universal scale, where those levels of precision seem to matter. And so we get certain things like these types of extensions that give you, just a range that generally most cases, 99.999999 don't actually care about. So, so go back to your app owner and just give them, right, more expensive, cumbersome, logic bug, blah, 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 or we drop one thing in precision, and then it's super simple to do this conversion and nobody has a problem. And I think, part of this that I wanted to sort of impress upon this person, but really I think people in general with this, is that, there's times like when you say like, well, DBA is like, database administrator, right? Or maybe it's database analyst, right? Like there's people have different, and to me, like sometimes, it's database advisor. And you need to go in and give the advice that the person, the application owner actually needs to hear, which is like, this is a bad idea to try to preserve this precision, and let them give you the pushback of like, no, we absolutely have to have it. And there's a particular requirement that requires the 7 digits of precision. Understanding like this is a big trade-off, right? We are definitely going to make our lives worse trying to support this. And so if we don't need it, if there's any way we can get out of it, we definitely should try to get out of it. And as the database person, you're giving the expertise to whomever, if it's a coworker or, somebody in another department, or whoever is the application owner, if it's a client, doesn't really matter. Like provide the expertise of like, hey, this is a bad idea. Let's not support it if by any way we don't have to. So hopefully that will hit home with the person and they can get by with that. The other thing I kind of wondered was if they could change the precision on the SQL Server side, because as I think it was in the last office hours I mentioned, like I'm always a fan of if you can change the data at the source to make it compatible with whatever it's going to be in Postgres, that's always a better move. So maybe that would be an option for them. But anyways, I just thought like it's kind of an interesting scenario that you see the person walking towards you, like this is going to be horrible if you have to end up doing this. And certainly if it runs for any amount of time, like if you have this in the long term, what we're doing is we're taking time values and storing them as text and indexing them in weird ways. You just don't want to be in that situation. Like somebody like 3 years from now is going to come and look at this application and be like, what the bleep were they doing? Like, why would you do this? And not understand like, the 7, and they were like, what? We don't even need any precision. Like down to the second would be good enough, right? Not like hundreds or 100,000ths of a second. No one actually cares. So anyways, I just thought I'd sort of share that, like I said, sort of question / story. Hopefully you find that either insightful or amusing, as I kind of did. So that's it for this session. I will probably be back in a week or two. I reckon once I get back into Florida, I'll do another one. And until then, hopefully we'll, stay warm if you're not warm like me. Otherwise, take care of yourselves. If you can, take care of a database as well. And I will see you in the next one. See ya.